So we have a quiz over types of reactions coming up, and this is your quiz review. So please watch this short quiz review and then take the quiz, please. We've been doing this for quite some time. I just thought it would be good to have an extra review. A little bit of a definition. Chemical equations need to be balanced because the answer is atoms are neither created nor destroyed in a chemical reaction. Atoms are neither created nor destroyed ever. Okay, you're going to learn that. So chemical reactions have to be balanced because you can't make any more or make any less. They just kind of move around. Okay, this is the definition. You'll be asked this on your quiz. True or false? Energy is required to break a chemical bond. That is true. It is an endothermic reaction. When you break chemical bonds, when we added baking soda with vinegar, it got cold. The reaction, the vinegar and baking soda made a bunch of bubbles, blew the balloon up, but it got cold. That was an endothermic reaction. Look at this molecule here. You have three O2s. I want you to look at the numbers and name them, the 3 and the 2. Which one is the subscript and which one is the coefficient? The subscript is the submarine. It's the lower one. So the 2 is the subscript and the 3 is the coefficient. Okay, that's the number that we change to get things to balance. Chemical equations are balanced by modifying the what? The subscript or the coefficient? It's the coefficient of the chemical formula, the big number. 3, the big number is called the coefficient. The little number that's down is called the subscript. We need to balance this chemical equation. So let's balance this. All right, so we've got 1 sodium here, 2 sodiums there, so we need to put a 2 in front here. Let's look at the hydrogens. We have 2 hydrogens here and 2 hydrogens here, and we only have 2 hydrogens on the right side. So we have 4 on the left, 2 on the right. So we got to get 4 on the right and 4 on the left. Okay, so we've got the sodiums balanced. We have the hydrogens balanced because there's 2, 4, and then there's 2 times 2. There's 4 on the right. Let's look at the oxygens. We've got 2 and 4 is 6. Oxygens on the left are 6. Oxygens on the right are 2 plus 4 is 6. 1 sulfur, 1 sulfur. So the proper way to balance this is 2, 1, 2, 1. Okay. Let's go over this one. The reason why I had these in there is I did this whole video once already and my mic wasn't turned on. So I'm doing it again for you. Let's balance this chemical equation here. We have 1 carbon, 4 hydrogens, 2 hydrogens. Let's put a 2 there. That gives us 4 hydrogens on the right side. Carbons are balanced. Hydrogens are balanced. Let's look at oxygen. We have 2 plus 2 is 4. We only have 2 here. We have 4. So it is 1, 2, 2, 1. What type of reaction is this? Remember, we had to name the types of reactions. What type is this? Well, when there's only CO2 and H2O, it is a combustion reaction. Here's another definition. An exothermic reaction is when energy is transferred from the reactants to the surrounding. From the left side to the surrounding, right? So when you burn wood, it's from the reactants to the surrounding. Exothermic reactions are warm. Define an endothermic reaction. Energy is transferred from the surroundings to the reactants. Endothermic reactions are cold. Vinegar and baking soda, the reaction got cold. That was an endothermic reaction. Here's some examples of different reactions for you. Fire is exothermic, right? It's out, heat goes out. Melting of ice is endothermic. Heat has to go in to the ice to melt it. The making of ice cubes is an exothermic reaction because the heat has to come out of the water to make ice. Okay. And baking soda in water was an endothermic reaction because it was cold. It got colder. Water is an exothermic reaction because the heat has to come out. So hopefully you can remember those. Types of reactions, remember that was combination or synthesis, mostly combination. That's on the quiz, it'll be called combination. It's when things join together. Decomposition is when things break apart. Single replacement is when just one of them changes and flips with the other product in the reactant. Double replacement is when they both flip in the reactants. And combustion is when there's only CO2 and H2O as a product. Let's look at some examples of type of reactions. You don't have to worry about balancing them on the quiz. They're already balanced. You just have to figure out what type of reaction they are. I would really recommend you don't even look at the numbers. Just look at the main chemicals. The main chemical here is Fe all by itself, O2 all by itself, and then over here Fe and O are together. So that is what we call combination or synthesis. Zn here is by itself, H is with Cl, and then Zn joins Cl. So this joins this, Zn joins the Cl, and H is now by itself. That's a single replacement. The Zn just replaces the H, and the H comes out by itself. Ni is with Cl. They're joined together, and then Ni and Cl just break apart. That is decomposition. C, H, and O are separate, and then C, H, and O are together. That is called combination. Li and capital I. Li is with capital I. Pb is with the NO3. And then Li is with the NO3. And Pb is with I. So that's a double replacement. The Li switches with the Pb and the Pb switches with the Li. CD and CO3 are together, and then CD and CO3 break apart. That's decomposition. Cl is by itself. K is with Br. K switches with, K goes with Cl, and then Br goes by itself. That is a single replacement. And this last one, CO2 and H2O are the only thing that is in the product, so that is combustion. Okay, hope that helps. Take your quiz, and that'll be it for the day.